In this video, let me explain how to find the solution of algebraic and transcendental equations. In most of the problems in engineering analysis, we have to face the situation that for a given function f of x, we have to find the value of x for which f of x is equal to 0. The solution or the value of x is known as the root of the given equation f of x equal to 0. Or in other words, I have to explain this as for the given equation f of x equal to 0, we have to find the value a such that f of x a is equal to 0. Here a is known as the root of the given equation. So here we have to find the root of the given equation. Whenever I say it is an equation, there are two types of equation generally we have discussed. One is algebraic equation and the other one is transcendental equation. Algebraic equations are equations which consist of the algebraic terms. That is, for example, x square plus x minus 1 is equal to 0 is an algebraic equation. That is, this equation consists of different powers of x. Likewise, I have to write the cubic equation x cube plus 5x square minus 3x plus 5 is equal to 0. It is an algebraic equation. So, algebraic equation consists of only algebraic terms. If so, then we say that type of equations as algebraic equations. Whereas in case of transcendental equation, that doesn't consist of any algebraic terms. It consists of only non-algebraic terms like trigonometric functions, logarithmic functions and exponential functions. For example, x sin x minus x is equal to 0. It is a transcendental equation because it consists of the trigonometric function. Maybe it may be sin x, cos x, tan x, secant, cosecant, whatever that may be of trigonometric function. And logarithmic function like x log x minus 1.2 is equal to 0. This is a transcendental equation because it consists of the logarithmic function log x. Likewise, e power x minus x is equal to 0. It is a transcendental equation because it consists of the exponential function e power x. So, algebraic equations are equations which consist of only algebraic terms, whereas transcendental equations consist of non-algebraic terms like trigonometric, logarithmic, exponential. So, now we have to find the root of the equation f of x equal to 0. Whether it may be algebraic or transcendental. So, there are two methods are available to find the root of the given equation f of x equals 0. The one is direct method, the other one is indirect method or iterative method. So, using direct method we can find the exact value of the equation. So, direct method gives you the exact value of the given equation in a finite number of steps. For example, you know the solution of an equation ax plus b is equal to 0, isn't it? That is, x is equal to minus b by a is the root of this equation. And for a quadratic equation ax square plus bx plus c equal to 0, you know the root of the equation, isn't it? That is, x using the formula x is equal to minus b plus or minus root of b square minus 4ac by 2a. Using this, you get the two roots of this equation. For a cubic equation 2, you get ax cube plus bx square plus cx plus d equal to 0. We are having some analytical methods are available to find the root of the equation. Suppose if it is of higher order, that is more than 3, it doesn't have any analytical methods or direct method available to find the root of the given equation. In such cases, we move on to indirect method or iterative method to find the solution of the given equation. So, here the indirect method follows the concept of successive approximations. There are so many methods are available to find the root of the given equation using indirect method. Among this, we are going to discuss about bisection method, regular fallacy method, iterative iteration method, Newton-Raphson method, secant method and Muller's method. In this video, let me explain how to find the solution of algebraic and transcendental equation using bisection method. It is one of the simplest and most reliable numerical method to find the root of the given equation. Based on the name itself, you understand that bisection. That means it divides the interval into two equal halves to get the root of the equation. That is, it separates the interval and subdivides the interval for which the root of the given equation lies. So, for a given function f of x equal to 0, first I have to find the interval for which the root of the given equation lies. For that, let me find the two values a and b so that f of a and f of b are of opposite signs. Which means if one of them is greater than 0 means the other one less than 0. Or otherwise, if one of them is less than 0 means the other one greater than 0. So this means the root of this given equation f of x equal to 0 lies in the interval a comma b. So using bisection method, we have to subdivide this interval for which we have to find the root of the given equation lies till to get the desired accuracy. Let me explain this concept by taking a simple example. The first one, I have to take an algebraic equation, then we move on to transcendental equations, and using bisection method how to find the root of the given equation. That is what we are going to discuss. Find the real root of the equation x cube minus x minus 1 is equal to 0. This is an algebraic equation, consists of only algebraic term, isn't it? So using bisection method, let me explain how to find the root of this equation. And let me take the given function as f of x. So f of x is equal to x cube minus x minus 1. As I told you already, for a given function, we have to find the values of a and b for which f of a and f of b are of opposite signs. Which means for the given function, the root of the equation lies in the interval a comma b, isn't it? So for that, to find the values of a and b, let me start with the value 0. So substitute the value 0 for x, that is 0 cube minus 0 minus 1. That is minus 1, this is negative value, isn't it? Next, substitute the value 1. If I substitute 1 for x, that is 1 cube minus 1 minus 1. Simplifying this, you get 1 minus 2, that is again negative. There is no change of sign. So we have to move on to the next value. So 0, 1, next one 2. If you substitute x for 2, that is 2 cube minus 2 minus 1. That is 8 minus, adding these two values together you get 8 minus 3, that is 5. This is a positive value, isn't it? That is a change of sign. So initially we get negative value, then we get negative value, here we get positive. If there is a change of sign, which means the root of the equation lies in this interval, that is in this interval 1 and 2. This is the value of a and b for which f of a, that is f of 1 and f of 2 are of opposite signs. Therefore, the root of the given equation lies in the interval 1, 2. This is 1 and 2. At f of 1 you have negative value and f of 2 you have positive value. Next I am going to bisect this interval to get the next approximation. So bisect this interval to get the next approximation, that is x1. Let me start with x1. So adding the two interval that is adding the 2 points 1 and 2 and divide this by 2, you get 1 plus 2 is 3. 3 divided by 2, you get 1.5. So bisecting this interval, you get the point 1.5 is the center point of this interval. So at this point, we have to find the value of f of x, that is f of x1 is equal to, that is f of x1 is 1.5, isn't it? So let me replace the value of x by 1.5 here. So 1.5 the whole cube minus 1.5 minus 1. Simplifying this value, we get now 1.5 the whole cube minus 1.5 minus 1, which equals 0.875. This is a positive value, isn't it? 0.875. This is positive. So at 1.5, the function takes the value positive. So now the root of the given equation lies in this interval. That is 1 to 1.5, isn't it? Because there is a change of sign here, minus positive. That is here positive positive, which means you omit this extra part. So the length of the interval now reduces from 1 to 2 to 1 to 1.5. Next we have to bisect this interval, that is 1 and 1.5. Next you have to bisect this interval and find the value of this value at this position and find the value of this function. Like this, we have to use the bisection method. We have to find the root with the desired accuracy. Let me list out all these iterations in a simple table. Let me list out all the successive approximation in a table format like this. Whereas in the table, I have to take the first column as iteration, the second column as the point A value and B, and third column I have to take x is equal to a plus b divided by 2 and f of x is equal to x cube minus x minus 1. This is for the given function. So in the first interval, we have to find the root of the given equation lies in the interval 1 and 2, and bisecting this interval we get the point 1.5. So that is bisecting this interval means you have to add the 2 points 1 and 2 and divide this by 2, you get 1.5. At this point you get the value of the function is positive. At 1 you have negative value, at 2 you have positive value of the function. So at this point you get the value of function 0.875. So now the root of the equation lies in the interval 1 and 1.5. So in the second iteration, you have to replace the value of x. That is, you have to replace this value of b by 1.5. So now the root of the equation lies in the interval 1 and 1.5. Adding these two values together, you get 1 plus 1.5 and divide this by 2, you get 1.25. So at this point you get the value of the function f of x as 1.25 the whole cube minus 1.25 minus 1, which equals minus 0.2968. We have to take up to 3 decimal or 4 decimal places as we like. So minus 0.2969. So bisecting this interval 1 and 1.5, you get the value 1.25. At this point the function takes the value negative, which means now the root of the equation lies in the interval 1.25 to 1.5, isn't it? The root of this equation lies in the interval 1.25 to 1.5. So now you have to replace the value of, since it is negative, you have to replace the value of 1 in the third iteration. So in the third iteration, so the value 1 is replaced by 1.25 and 1.5 for B. So adding these two values, that is 1.25 and 1.5, you get 1.375. At this point you get the value of the function plus 0.2246. Since the value is positive, so in the fourth iteration you have to replace this 1.5 by 1.375. So in the fourth iteration, 1.25 as A value and 1.375 as the value of B, and adding these two values together you get 1.25 plus 1.375. Adding these two values and divide this by 2, you get 1.3125. So at this point the function takes a value minus 0.0515. This is a negative value. Since it is negative, you have to replace the value 1.25 by 1.3125, isn't it? So at the fifth iteration, we have the value of A as 1.3125 and the value of B as 1.375. Adding these two values together, that is 1.3125 plus 1.375, and divide this by 2, you get 1.34375. That is, I have to take up to 4 decimal places. So 1.3438, because in the fifth decimal I have the value 5. So you have to add 1 with the previous decimal. So 1.3438. So at this point the function takes the value 0.0828. That is positive. So if it is positive, you have to replace the value of B, that is this one, by 1.3438. So in the sixth iteration, the value of A as it is, you have to replace only the value of B by 1.3438. So adding these two values, that is 1.3125 plus 1.3438 and divide this by 2, you get 1.3282. Since in the fifth decimal you have 5, so add 1 with the previous decimal. So 1.3282 is the value of x. So calculate this at this value, calculate value of f of x. So calculating this value of f of x, you get 0.0149, that is positive value. If it is positive, again you have to replace this value by this one, that is in the seventh iteration. So 1.3125, there is no change in the value of A. You have to replace the value of B by 1.3282. So adding these two values together, 1.3125 plus 1.3282, you get 2.6407, and you divide this by 2, 1.3204. So 1.3204 is the value of x. At this point you get the value of the function, that is negative value. If it is negative, you have to replace this value of A in the next iteration. So you have to replace the value of A by, that is 1.3204, and there is no change in the value of B now. So adding these two values likewise and divide this by 2, you get 1.3243. At this point you get the value of the function is negative. If it is negative, so you have to replace this value of A in the next iteration, that is in the ninth iteration. If you have to replace this value of A by 1.3243, and there is no change in the value of B, so adding these two and divide this by 2, you get 1.3263. So at this point you get the value of function as 0.0068, that is positive value. If it is positive, you have to replace the value of B. If you have to replace the value of B and taking the same value of A in the previous iteration and adding these two and divide this by 2, you get 1.3253, and at this point you get the value of the function is positive value, that is 0.0025. If it is positive, so again in the next iteration you have to replace the value of b by 1.3253. So in the 11th iteration, no change of the value of a in the previous iteration, but you have to change the value of b by 1.3253. So adding and divide this by 2, you get 1.3248, and at this point you get the value of the function as that is 0.003, that is a positive value. So if it is positive, again you have to replace the value of b in the next iteration. So that is at the 12th iteration. So you take the value of a as it is and replace the value of b by 1.3248, and adding these two values and divide this by 2, 1.3246 you get. So at this point you get the value of the function as negative. Let me start this iteration up to this, since I have to get the root with the desired accuracy up to 3 decimal places, isn't it? This is 1.324. Here itself I get 1.3246. So here I have to take up to 3 decimal places. So the root of the given equation is 1.325, because in the 4th decimal in these two cases here 8 and 6. So you have to add 1 with the previous decimal. So the root of the given equation is 1.325. Now let me show you how the graph of this function looks like. That is x cube minus x minus 1. This was the given function, that is x cube minus x minus 1. If you plot this function in a graph sheet, you get a graph like this, and just trace the curve to get the coordinates. So this curve intersects both x-axis and y-axis, isn't it? So it cuts the y-axis at minus 1 and cuts the x-axis at (1.32). So the curve where it cuts the x-axis, that is the x-intercept, always gives you the root of the given equation, isn't it? It cuts the x-axis at 1.32. So that gives you the root of the given equation. But using graphical method to find the root of the given function is highly impossible. That is it's a difficult task to find the root of the equation using graphical method. But for your understanding, let me show you this graph of the function, how it looks like and how to find the root using this graphical method. So the graph of the given function look like this. It cuts the x-axis at 1.32. So that is the root of the given equation. Let me now move on to next example. Find a real root of the equation x e power x is equal to 1, which lies between 0 and 1. Here f of x is equal to x e power x minus 1. Let me take, if you take this equation as x e power x minus 1 is equal to 0, so you have to take this function as your f of x. As usual, first we have to, since the interval also given already, we have to verify. So let me start with the value 0, 0 e power 0 minus 1, that is whatever may be the value of e power 0, whenever you multiply with 0 you get 0, minus 1 is minus 1, that is negative value. And next substitute the value 1, that is 1 e power 1 minus 1, that is equal to e power 1 minus 1. You know already the value of e is 2.7, etc. So if you don't know, you just press e in your calculator and get the value of e. So 2.7 minus 1, that is 1.7. This is positive. So there is a change of sign, that is negative to positive. Therefore the root lies in the interval 0, 1. At the point 0, the function takes a negative value. At the point 1, the function takes positive value. So here I have to take, in the table, I have to take the value of a as 0 and b as 1. So now, using bisection method, we have to bisect this interval into two equal halves, that is 0 plus 1 divided by 2. That is, bisect this interval to get the next approximation, that is 1 plus 0 divided by 2, that is 0.5. So at this point, that is f of 0.5, what is the value of the function? That is what we have to find. So here your f of x is x e power x, that is 0.5 e power 0.5 minus 1. Simplifying this, you get 0.5 product exponential power 0.5, that is equal to minus 1. You have minus 0.1756, that is you get the negative value. Minus 0.1756, that is negative value. So at 0.5 you get the negative value. The function takes negative value. Now the root of the interval lies in the interval 0.5 to 1. So you omit this part in the first iteration. Let me now list out all the successive iterations in a table form like this. So in the first iteration, we have to find the root of the equation lies in the interval 0 and 1. Initially we have to find the root of the equation lies in the interval 0 and 1, and adding and divide this by 2 you get 0.5. At 0.5 the function takes the value minus 0.176, that is negative value, isn't it? If it is negative, so you have to replace the value of a, since it takes a negative value. So the second approximation, you have to replace the value of a, that is 0 by 0.5, and b by as it is, that is the value 1, and adding and divide this by 2 you get 0.75. So at this point you calculate the function f of x, that is 0.5878. That is positive. If it is positive, you have to replace the value of b in the next iteration. So 0.5 and b as 0.75, adding and dividing the value by 2.625. So at this point you get the value of f of x as positive value. So if it is positive, again you have to replace the value of b, that is 0.75 by 0.625. So and adding and divide the value by 2 you get 0.5625. So at this point you get negative value. So in the fifth iteration, you have to replace the value of a, that is 0.5 by 0.5625. So take the value of b as it is, as usual, add and divide the value by 2, and at this point you get the value of the function is positive. If it is positive, you have to replace the value of b, that is b by 0.5938. So add and divide by 2 you get 0.5782, and at this point you get the positive value. If it is positive, in the next iteration you have to replace the value of b, that is by 0.5782, and add and divide by 2 you get 0.5704. So at this point you get positive value. If it is positive, next iteration you have to replace this value of b by 0.5704. So add and divide this by 2 you get 0.5665. So at this point you get negative value. If it is negative, again you have to replace this a value, but that is 0.5625 by 0.5665. So take the value of b as it is, as usual calculate the value of x. At this point you get positive, and again if it is positive, replace the value of b by 0.5685. So calculate value of x, and at this point you get again positive value. So if it is positive, again you have to replace the value of b by 0.5675 and calculate the value of x. Here itself you get negative value. If it is negative, replace the value of a, and at this point you get 0.5673, get the function value positive. So I have to stop this process up to this, because the successive approximation I have to find that 0.567 here 0.5673. So I get the root with the desired accuracy up to 3 decimal places. So the root of the given equation is 0.567. Let me now show you how the graph of the function look like. That is x e power x e power x minus 1. If you plot this curve in a graph sheet, you get a graph like this. This is the second graph. And just delete the previous one. So if you plot this in a graph sheet, you get a graph like this. So it cuts both x-axis and y-axis. Where it cuts the x-axis is the solution or root of the given equation. That is x-intercept 0.57. It cuts the x-axis at 0.57. So that is the root of the given equation. So if you plot the graph in a graph sheet, you get a curve like this. Here the x-intercept gives you the root of the given equation. That is 0.57. It cuts the x-axis at 0.57. So that gives you the root of the given equation. This is for your understanding purpose. If you plot the curve in a graph sheet, how it look like. Let me now move on to next example. Find the real root of the equation x minus cos x is equal to 0. This is a transcendental equation because it consists of the cosine term. Trigonometric function cosine. So trigonometric functions like sine, cosine, tan, secant, cosecant, cot. So if the equation consists of any of the terms like this, you have to take that as a transcendental equation, and also make sure that the mode of the calculator is in radian mode. So whenever you are evaluating the root of the given function, your mode of the calculator should be in radian, not in terms of digit. So while we are evaluating the root of the functions like logarithmic or exponential or an algebraic equation, our mode of the calculator is in terms of digit, that's not a problem. So we always keep our mode in that is degree. So if it is in terms of, that is an equation involving the trigonometric function, your mode of calculator is in terms of radian. Now let me start with our procedure. As usual, we have to take the given function as f of x, that is x minus cos x as your f of x. Instead of substituting the value 0, 1, 2 like as we do in our previous problem, since it is a problem involving a transcendental function, that is like trigonometric functions, so we have to substitute the values for x as 0, pi by 6, pi by 4, pi by 3, pi by 2 and pi. So you know pi by 6 is 30 degree. So if you substitute first for 0, let me start with 0 as usual. So f of 0 is 0 minus cos 0. So the cosine value of 0 is 1. So that is minus 1. This is negative, isn't it? Next we substitute the value of x by pi by 6. So if you substitute the value of x by pi by 6, that is pi by 6 minus cosine pi by 6. So evaluating this, you get, before calculating this, let me check what is the mode of the calculator. So this is in terms of degree. I have to change this in terms of radian. That is one more mode, radian is available. So if you just change this to radian, you press this, it will change. In your calculator there is an option 1, 2, 3. You just accordingly you have to input the option, that will automatically convert it into radian. So now my mode of the calculator now is in radian mode. Now I calculate pi by 6, that is equal to 0.523 etc. minus cosine value of pi by 6, that is equal to minus 0.3424 etc. So f of pi by 6 value is, that is negative value I have to. Now pi divided by 4, this equals minus cosine pi by 4, that is equal to positive value 0.078 etc. That is positive value, isn't it? So at this point you get positive value. Here look at here, there is a change of sign from negative to positive. Therefore the root lies in the interval pi by 6 comma pi by 4, that is pi by 6 to pi by 4. At pi by 6 the function has negative value, so I have to take this as my a value. At pi by 4 the function takes the positive value, so I have to take pi by 4 as b value. So instead of taking the values in terms of pi, let me convert this in terms of digits, like that is pi by 6 means whenever you divide the value of pi by 6 you get 0.5236. So pi by 6 value in terms of numbers is 0.5236 and pi by 4 in terms of numbers is, that is 0.7854. So the root lies in the interval, so our pi by 6 is 0.5236 and 0.7854. So the root of the equation lies in the interval 0.5236 and 0.7854. So you have to take this as your a value and this is your b. At this point the function has negative value and at this point the function has positive value. Now you have to bisect this interval to get the next approximation. For that you have to add and divide this by 2. Let me list out all this in a table form like this. So in the first iteration, so I have to get the interval for which the root of the equation lies is, it is 0.5236 to 0.7854. Adding and divide this by 2 you get 0.6545. At this point the function takes the value negative. If it is negative, you have to replace the value of a in the next iteration by 0.6545. Take the value of b as it is. As usual, add and divide this value by 2 and at this point the function takes negative value. So if it is negative, again in the next iteration you have to replace the value of a by 0.71995 and take the value of b as it is. Add and divide these two values, you get 0.7523. At this point you get the value of the function is that is a positive value. So in the next iteration, if it is positive, replace the value of b by 0.7523, take the value of a as it is and add and divide these two values by 2, you get 0.7361. At this point you get the value of function negative. So if it is negative, so you have to replace the value of a by 0.7361 and take the value of b as it is and adding these two values and divide this by 2 you get 0.7442 and at this point you get positive value. So if it is positive, so you have to replace the value of b by 0.7442 in the next iteration. So adding and dividing these two values you get 0.7402. At this point you get positive value. So in the 7th iteration, if it is positive, again you have to replace the value of b by 0.7402 and adding and dividing these values by 2 you get 0.7382. At this point the function takes a value minus 0.0015. That is negative. If it is negative, replace the value of a in the next iteration and take the value of b as it is and adding and dividing these two values 0.7392 and at this point you get the value of the function positive. If it is positive, you replace the value of b in the next iteration calculating the value of x. At this point the function takes negative. If it is negative, again you have to replace the value of a by 0.7383 and adding and divide this by 73895. At this point the function takes negative. If it is negative, replace the value of a and you get the value of x as 0.7391. At this point the function takes positive value. If it is positive, replace the value of b and add and divide by 2.739 you get. At this point the function takes a negative value. So let me start this process up to this, because I have to get the root with the desired accuracy. That is, up to 3 decimal places only I need the root of the given equation. Therefore, the root of the given equation is 0.739. Let me show you how this graph of the given equation looks like. Now, x minus cosine x. Cosine x. X minus cos x, isn't it? So, if you plot this in a graph sheet, the curve look like this. So, it cuts both the x-axis and y-axis. Where it cuts the x-axis gives you the root of the equation. That is, x-intercept always gives you the root of the equation. So, it cut both x-axis and y-axis. So, let me find at what point it cuts the x-axis. It cuts the x-axis at 0.74. So, that is the root of the equation, isn't it? So, if you plot this in a graph look like, and it cuts the x-axis at 0.74, that gives you the root of the given equation in a graphical method. This is for your understanding purpose only. If you plot the curve, how it look like and how to get the root of the equation. Let me now move on to next example. Find the real root of the equation x log x minus 1.2. So here as usual you have to take the function f of x as x log x minus 1.2. So let me start at the value 0. That is, first we have to find the interval for which the root of the equation lies. For that, replace the value of x by 0, x log 0 minus 1.2. So log 0 is minus infinity. So if you multiply with 0, you get 0 minus 1.2, that is negative. Then f of 1, that is 1 log 1 minus 1.2. Log 1 value is 0. So whenever you multiply 0 with any value, you get 0. Again you get negative value. Next we move on to 2. 2 log 2 minus 1.2. 2 product log 2 is equals 0.6 and minus 1.2, that is equal to minus 0.59, that is negative value. So of f of 2 you get negative value. So we move on to next, that is, if you replace the value by 3, that is 3 product log 3, that is equals minus 1.2 equals positive value. So of f of 2 you get negative value and f of 3 you get positive value. That is, so at f of 2 you get negative value and f of 3 log 3 minus 1.2, that is positive. So that is change of sign from negative to positive. Therefore, the root lies in the interval 2, 3. So at f of 2, that is, the function takes the negative value, and f of 3, at f of 3 the function takes positive value. So here I have to take a as 2 and b as 3. Now bisect this interval to get the next approximation, that is adding and dividing these by 2, you get 2.5. So at 2.5, let me first find what is the value of the function at this point, whether it may be positive or negative. Now let me restore all this successive approximation in a table format. First column consists of iteration. That is, the first iteration we have to find the interval for which the root of the given equation lies is 2, 3. At the point 2 the function takes negative value, and at the point 3 function takes positive value. So bisect this interval into 2 equal halves, you get 2.5. So at 2.5 the function takes negative value, that is x log x minus 1.2 at this point is negative. So if it is negative, replace the value of a by 2.5, take the value of b as it is. Adding and dividing these two values by 2, you get 2.75. At this point, you get positive value. So if it is positive, replace the value of b in the next iteration. So add and divide these two values by 2, you get 2.625. So at this point, you get negative value. If it is negative, replace the value of a in the next iteration by 2.625. Take the value of b as it is and add and divide these two values, you get 2.6875. So at this point, you get negative value. If it is negative, replace the value of a again by 2.6875 and take the value of b as it is and add and divide this value by 2, you get 2.7188. At this point, you get negative value. So if it is negative, again replace the value of a by 2.7188. Take the value of b as it is. So add and divide this by 2, you get 2.7344. So at this point, the function takes negative. So if it is negative, again replace the value of a by 2.7344. Take the value of b as it is, add and divide this by 2, you get 2.7422. At this point, the function takes positive. If it is positive, you have to replace the value of b by 2.7422 and add and divide this by 2, you get 2.7383. So at this point, the function takes negative value. If it is negative, you have to replace this value of a by 2.7383. Take the value of b as it is, add and divide this by 2, you get 2.7403. At this point, the function takes negative value. If it is negative, again you have to replace the value of a by 2.7403. Take the value of b as it is, add and divide this value by 2, you get 2.7313. And at this point, the function takes negative value. If it is negative, again you have to replace the value of a by 2.7413. Take the value of b as it is, add and divide this by 2, you get 2.7418. And at this point, you get positive value. If it is positive, so you have to replace the value of b by 2.7418. So at this point, add and divide this by 2, you get 2.7416. And at this point, you get negative value. Let me start this process up to this, since I have to get the root with the desired accuracy, that is up to 3 decimal places. So the root of the given equation is 2.742. Hope you got a clear idea about how to find the solution of algebraic and also transcendental equations using bisection method. Thanks for watching. See you again in my next video.